Okay, we're going to go over the review for the Chapter 8 worksheet. So a couple of symbols that you need to know for your test. So your level of significance is always going to be your alpha. Your symbol for your best point estimate of the true proportion is going to be your p hat. Make sure, so if you forget this, if you look at the formula, you'll see that the formula is like p hat plus or minus, and it has the rest of the equation, which is the error. So this is your point estimate for proportion. So for true mean, it's x bar. I do realize that true proportion and true mean are the mu and the p, but remember this is our point estimate, which means it's going to refer to those other values. Okay, the symbol which represents the critical value used in interval tested for means is our T star. For proportion, it's Z star. The symbol for the margin of error is E. Remember on your formula sheet, you will see, it'll say confidence intervals. So remember that it's p hat or x bar, plus or minus your error. So plus or minus your error. So on the formula sheet, the formula that's sitting here in this place is your margin of error. So you have to find margin of error, and that's it. You're going to do that formula in that spot on the formula sheet, so that kind of helps you out. Okay, so confidence intervals for critical value for, we just covered that. Sorry, I thought it was down there. So that's your Z star. Okay, remember, use that formula sheet as kind of a check so you can see, it'll kind of give you hints on what things are, what formulas are. So a sample mean, x bar, is called the point estimate of the population mu. So remember, we're using that sample to guess at the population. Okay, find the critical value of a one sample proportion with 90% confidence. Okay, critical values come from our table. If it is a Z, or if it is a proportion, we use our Z table. So at the bottom of your Z table, it says critical values, and you would look 90% confidence and see that that was 1.645. If I do the critical value for one sample means with 80%, this is just a number that you're going to want to kind of memorize, and it's the 1.28. Remember, on both of these, I don't need to know the sample size. The confidence interval for the mean length of a frog jump is 12.64 to 14.4. So to find the point estimate, so remember, it's 12.64 to 14.44. In the middle is our point estimate, and the difference from our end to our middle, or middle to the either end, is our error. So we average those two numbers, divide by 2, and we get 13.54, which is going to be our point estimate. Then to get the error, it's going to be that point estimate, and I just subtract the lower number. If you ever want to be sure, if you did 14.44 minus 13.54, that also would equal 0.09. So either one you do, you're going to get the same answer. Can we conclude that the mean length of all frog jumps is more than 13 centimeters? Well, so if we look, our interval went from 12.64 to 14.44. Let me write this up this way. So 12.64 to 14.44. Well, 13 is here. So in order for this to be true, the statement has to contain the entire interval. The statement does not contain the entire interval, so we cannot conclude. So entire interval is not within the claim. So this is kind of what you need to know. This is just kind of extra so you understand. Okay, so what does 95% confidence mean? It is not a chance. It is not a probability. Okay? It is, we can say it two ways. If I did repeated sampling, 95% of those intervals would contain that true population mean. So if you remember the notes, we had this, and this was our true population mean. And then these were all of our samples. Okay, sometimes they landed in, sometimes it was middle. So like this interval contains the population mean, this one does not, this one does. So if I did this 100 times, 95 of these would contain inside their interval the population true mean. So that's what that means. It also, we can phrase it, say 95% of the confidence intervals we construct after repeated sampling, so notice both of these are saying that, would come in, and there's our interval. The main thing on this one is to remember that it's not probability, it's not chance, it's confidence, which is what it's saying here. It said I'm 95% confident. Okay, what would cause the width of an interval to decrease? So if this was 90% confidence and I went down, I'm going to, so one thing I can do is I decrease my confidence. So I could go from 99 to 95. That would decrease my confidence interval. Okay. If I was 95% confident and this was with a sample size of 10 and I went to a sample size of 100, because I have more data, which allows me to make a better guess, my 95% confidence interval would be smaller. So if I increase the sample size, it will decrease the width of my interval. An agriculture researcher plants 25 plots with new variety of corn. An average of the yield is, so there's my X bar. Assume that the yield per acre for the new variety of corn follows a normal distribution with an unknown mean. I have a standard deviation and a confidence interval. Okay, so this confidence interval, remember, this is going to help me get that Z star. So it's going to be that 150 plus or minus, this comes from our, it would be our T star because it's a mean. So we would do our degrees of freedom. So my degrees of freedom would be 24. And I would find that T star value, which will give me, let's see if we can find our T star. So 24, so 90% confident, 24, 1.711. So 1.711. So if I say 1.711 times 10 divided by the square root of 25, it's going to give me 150 plus or minus 3.422. So this is going to be my confidence interval. I can either write it like this, or I can write it where I multiply things out, or add and subtract things. In a college, 365 college students, 60% claim to be sleep deprived. Construct a 90% confidence interval for the proportion of all TVOU students who are sleep deprived. So our Z star is going to come from the table with 90%. Remember, that's under our critical values. So that's going to be 1.645. We have our N and our P hat. So usually when I'm doing this, if I have P hat, I turn around and find 1 minus P hat just to make typing this in easier. So my Z star came from here. I put the rest of these into my formula, and I'm going to get a confidence interval of 0.5589 to 0.6412. Remember, these are proportions, which means all of them should be greater than 0 and less than 1. Beyond representative sample, what assumptions are need to be met? So for a proportion test, so if it's a proportion, it needs to be binomial, and I need to have a big enough sample size. So the number of successes and failures should both be at least 5, and I'm following a binomial distribution. So sample size, this is only true for a means test. So this one is, so the difference between both of these have at least negative 5. And so this says should both be at least. Oh, this one says or. So in a binomial distribution, the sample size has to be big enough and it has to follow a binomial distribution. So make make sure if you're seeing two questions that look the same, that you look at them and find what the difference is. So the difference on in this one is that word and that word or. Beyond a representative sample, what's needed to find a one sample means. So this means X has to be normal, or my N has to be greater than 30. So you'll notice that both B and D are talking about a sample size of at least 30. The difference in here lies between that or and that and. So if my population is a normal distribution, I don't care about the sample size. I only care about the sample size if the normal, I don't know, it's either skewed or I don't know about it.